Hello, Oakland Unified School District teachers. I am so happy to be talking with you today about Grade 5, Unit 1, Addition and Subtraction with Fractions for Math Expressions. If we look at the standards in the unit, we have two major cluster standards. Basically, in this unit, we are going to be using our understanding of the place value system to be able to add and subtract fractions with like and unlike denominators. And we are going to also be able to compare fractions in order to see if our answers are reasonable. There's also a supporting standard from the measurement and data big idea, and that has to do with us being able to plot fractions on a line plot. And this relates back to comparing the sizes of fractions. So in this unit, students will use number lines to represent equivalent fractions, express fractions with unlike denominators in terms of the same unit fraction so they can be added or subtracted, use bar models to visualize a sum or difference, use equations and models to solve real-world problems, and use estimation to determine whether or not their answers are reasonable. So let's talk about fractions in context through the grade level. So fractions don't really show up until third grade. In second grade, they begin to talk about this idea of equal shares. In third grade, they actually name fractions and understand that a fraction is a representation of a part of a whole, with the numerator representing how many pieces of the whole they have and the denominator representing how many pieces are required to make a whole. And then in fourth grade, they started to look at this idea of equivalent fractions by comparing fractions in a bar model. And then they also began to think about this idea of adding and subtracting unit fractions, knowing that if I add up the same number of unit fractions as I have in the denominator, I will get 1. So for example, if I added 1/4 plus 1/4 plus 1/4 plus 1/4, I would have 4/4, or I would have 1 whole. So all of this is setting us up to in fifth grade, where we are going to start adding and subtracting fractions with unlike denominators as well. So in order to do this, we're going to want to start by reviewing some previous grade level standards. We're not stepping back, we're accelerating students towards the grade level standards. But we want to remind them of some of the mathematical models that were used so that they can make accurate models with the grade level work. So here we have some representation of unit fractions adding up to a whole. A third, and a third equals 3/3 or equals 1. In fifth grade, we're going to accelerate and build onto that idea with not just the repeated addition of 1/3, 1/3, 1/3, but now we're going to rewrite it or rephrase it as a multiplication equation. 3 times 1/3 equals 1. And this is going to be important when we are adding fractions of unlike denominators, and we want students to be able to, with some degree of fluency, add and subtract those fractions by coming up with equivalent fractions for those unlike denominators so they have a common denominator. And they don't have a whole bunch of fractions littering the page where they're adding up a third and a third and a third to see what they have. And we have another example on the bottom here where I can add unit fractions 1/5, 1/5, and 1/5 to get 3/5, or I could represent that another way as 3 times 1/5 equals 3/5. And again, this is really previous grade level standard, adding unit fractions together. and also subtracting with like denominators. We're going to build on this in this grade level so that we're using fractions greater than 1, and also, as I've stated before, fractions with unlike denominators. So let's get into the grade level work. So the first thing is we are thinking now about making equivalent fractions. So in 4th grade, we use the bar model, and that's where we're going to start here, and we're going to build onto that. So we can see the bar model represented here. We have 1/2 and another half to make a whole at the top. I want to make an equivalent fraction with fourths. So you can see I'm going to split it again, and I can see that 2/4 equal 1/2. And if I split it into thirds, I see 3/6 equal 1/2, 4/8 equal 1/2, 5/10 equal 1/2. And this is really 4th grade work, but we're starting here because we want to build on that same model. And we're going to add that algebraic representation, just as we did when we were adding up those unit fractions. Now you can see how that applies to making equivalent fractions. Now we're not just saying, well, we split it, we're showing it visually, we're representing it algebraically as well. So 1/2 times 2, because we took that 1/2 and we made it into 2 pieces, equals 2/4. 1/2 times 3, because we have that 1/2, we split it into 3 sections, equals 3/6, and so on. So we're representing algebraically. At this point, it's really important that students understand that that 1/2 times 2 halves is not times 2, it's not times 3, it's not times 4, it's times 2 halves, 3/3, 4/4, 5/5, and that those fractions, because their numerator and their denominator are equivalent, are equal to 1. And so we're not changing the value of the fraction. So students are going to walk away from this knowing how to represent equivalent fractions both on a bar model and algebraically, and they're going to understand that the equivalent fractions have the same value. And that's true whether we draw it out on the bar model and we can see that it takes up the same amount of space, or we write it algebraically and we have an understanding of fractions that represent one whole, and we know anytime we multiply something by 1, we learned this in 3rd grade, it retains the same value. So now we have an idea about how to make equivalent fractions. We want to start getting into this idea of how to compare fractions. So which fraction is greater, which fraction is lesser. Here's an example of 2 things that we want students to generalize at this grade level. So we want students to be able to look at 2 fractions where the denominator is common. So right here we have 3/5 and 4/5, and the denominator is the same, fifths. So I can look at those 2 fractions, and whether or not I drew the bar model, I should be able to understand that since 3 is a lesser number than 4, and that's the number of pieces, and 5 is the same for the denominator, and that's how many pieces it takes to make a whole, then the fraction with the greater numerator, because their denominators are the same, will be the greater fraction. If I look at the example in green, here I have 2 numerators that are the same, 2/5 and 2/7. But since I know that I'm going to have to take one whole and cut it into more pieces, 7 pieces, so each piece will take up less space than fifths, then I know that in this case, when the numerators are the same, the denominator that is a lesser number will actually have a greater value. So 2/5 would be greater than 2/7. So we want students to generalize, one, that if the denominator is the same, it means that the pieces of the two wholes that I'm comparing are the same size. If the denominators are different, then the lesser number actually has greater pieces, so that each piece takes up more space and has more value. Each unit fraction of that denominator is larger. So if I can generalize that, then I can generalize that when I'm comparing two fractions with common denominators, the fraction that has the larger numerator is greater. If I am comparing two fractions where the numerators are common or they're the same, then the fraction with the lesser denominator has a greater value. This isn't easy for students to conceptualize. It does take a lot of drawing visual models and writing out the comparison algebraically. It's better when students kind of discover this instead of just being told those generalizations. Being told and asked to memorize those generalizations is the hardest way they could possibly learn it. Discovering it by making these comparisons and saying, what do you notice about these two fractions? What's the same about them? And doing it over and over again and coming up with those generalizations will make this learning more real for students. So now we have talked about how to represent fractions. We've talked about how to make equivalent fractions. We've talked about comparing fractions. And that's building up to us getting to making fractions greater than 1 or mixed numbers. So here we have an example of a bar model. We have 5/4. Students in this unit are going to solidify their understanding that when the numerator is greater than the denominator, I know without any calculations or drawings that the fraction is greater than 1. And so we can draw that out. We can show that if I know the denominator is 4 and I have to shade in 5 pieces, I'm going to have to fill in that whole first hole of 1/4 plus 1/4 plus 1/4 plus 1/4. And then I'll have one more fourth that I have to color in, so I'll have to draw another hole. We want students to, in tandem with making these models, write this out algebraically. 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. I can circle the 4 1/4 that make a whole, and I can represent that that equals 1 1/4. And the reason we want them to be able to do that both on the model and algebraically is because that is going to lead us up to actually manipulating fractions and adding and subtracting them. So this is kind of the meat. This is what we're leading. All of these things up till now have been leading up to this practical application where we are going to add and subtract fractions. So we will start with fractions greater than 1 that are mixed numbers that have the same denominator. So here we have the example 1 2/3 plus 1 2/3. And we can see that the student has drawn out 1 2/3 to represent each mixed number. And then they've combined from the two sets of 2/3, 3/3 to make another whole. It's important that we give students opportunities to draw this out because they're building an understanding of what this is going to look like combining those fractional parts. And they're going to need that conceptual knowledge to determine whether or not their answers are reasonable in the future when they're not drawing out everything and they are just writing the fractions algebraically. And that's going to lead up to us adding fractions and subtracting fractions where the denominator is different. So these have an unlike denominator, and we're going to have to find a common denominator. I've displayed all the components of this leading up to finding the common denominator and being able to solve the problem algebraically. I don't want that to be misleading, though, and think that we're going to skip a bunch of steps and maybe teach the procedure for finding a common denominator. You're going to still want to start with your bar models. And students are going to draw out the unlike fractions so that they can see where there is some equivalence. So here we have 1/2 plus 1/3. And if I draw out those fractions, I can see that 1/2 has the same value as 3/6. 1/3 has the same value as 2/6. Because I did the work earlier in the unit of creating equivalent fractions, both with models and writing it out algebraically, I now have the skills to take that comparison and then show how I could make those equivalent fractions algebraically. Then I would rewrite my problem with the common denominator, and I would be able to, in this case, add them together. Simultaneously, because I can compare fractions, I'm going to be able to determine whether or not my answer is reasonable. I know that 1/2 is a benchmark fraction. I can picture that in my head. 1/3 I know is less than 1/2. I know I need 2 halves to make a whole, so it would make sense that my answer in this case would be less than 1 whole, because I have 1/2 and 1/3, which is not quite a whole, or not quite a half, and if I'm adding them together, it's going to be less than 1 whole. And so, of course, the students, the next thing would be directing them to model it added together, and here we have it added on the bar model, and then algebraically as well, we would end up with 5/6. So let's walk through this unit again. First thing we're going to do is understand representation of fractions, and we're going to really solidify our understanding of how to represent fractions. Moving forward, we're going to investigate equivalent fractions, starting with the bar model, moving into representing those fractions algebraically. Within this, we are going to start comparing fractions. And we're also going to be able to create equivalent fractions greater than 1. From there, we're going to take our understanding of how to represent fractions, both on the bar model and algebraically, and we're going to move into adding and subtracting with like denominators for fractions that are greater than 1. And from there, we're going to move into adding and subtracting with unlike denominators, being able to use our knowledge of equivalent fractions and comparing fractions to come up with common denominators, and then to determine whether or not our answer was reasonable. So throughout all of this, there's this idea that we are using visual representations to justify or guide or prove what we are stating algebraically. Please do not rush students through this unit to try and get to a procedure for common denominator. They really do need that rock solid understanding of the concept of equivalent fractions and that it can only be done through those visual models. In this presentation, we use the bar model, but in the curriculum, you'll note that it's also represented on the number line. So I hope you enjoyed this presentation of adding and subtracting with fractions. It is one of my favorite units to teach. It's also one of the most challenging units for students, but it is a lot of fun.